Hi everyone, this is Kalyan Kumar this side and welcome back to Chemistry Universe. We are doing amines and this is part 11 of amines. And in this one, we are going to do the separation of amines. How you are going to separate a mixture of primary, secondary and tertiary amines. There are three distinct reactions and three distinct ways of doing that I'm going to show you in this video. So let's get on with it. All right, so let's get on with separating primary, secondary and tertiary amines. The first is called the Hinsberg method. Reaction number 13, Hinsberg method. Now in this method, a mixture of amines can be separated by using benzene sulfonyl chloride. So this is what I do. First, I take a primary amine and show you the example. What will happen? This is benzene sulfonyl chloride. Now the nitrogen's lone pair is obviously going to attack the sulfur. The pi bond will shift to O. Attack again and Cl will be lost. You will get, and this Cl will seek the H. And you will get this. And if you notice, this has an H. The nitrogen has an H. And this H is acidic because the negative charge can be distributed between these two O's by resonance. So the anion is stable and therefore the H is acidic. So this is soluble in a strong base. Soluble due to acidic H. But you can understand what will happen if it is a secondary amine, right? Because there won't be any H left. Everything will be the same except for the fact that it won't have an H and that won't be soluble in KOH. So it will be insoluble due to no acidic H. And for tertiary, there won't be any reaction at all because there is no H at all for the Cl to take. So tertiary will not react. The next one is called fractional distillation, which we already know what that is. The mixture of primary, secondary and tertiary amines can be separated by fractional distillation. And quaternary ammonium salts do not undergo distillation as they are solid. And we've already discussed that in physical properties of amines that primary amines have higher boiling than secondary have higher boiling than tertiary because of hydrogen bonding. So that way they would be distinguished. And the next one by which we can separate them is called a reaction with diethyl oxalate. It's called the Hoffmann method. Basically what you do is you take a diethyl oxalate. If you react it with a primary amine, just remember we are just trying to do the reaction. We're not going to go deep into why this happens, why this doesn't happen. We're just going to see what happens. Now if you take primary amines, two of them would react. And what will happen is the C2H5O will take the H from each. So you can just assume this part goes. This part goes. So you'll get 2-ethyl alcohol. And you will get a diamide. Okay. So when you use a diethyl oxalate, you're going to get a diamide if it is primary. If it is secondary, this is solid by the way. If it is secondary, only one will react. So in one case, you will get a secondary amide, the other will remain as an ester. This is actually a liquid. And tertiary amines do not react with diethyl oxalate. And that would be the end of separation of amines. So we are at the end of this video and watch the video as many times as you want. And if you have any pertinent questions regarding this, please do put them in the comment section below. But these reactions, I don't think require that much of a confusion because they're very simple reactions. So with that, this is Kalyan Kumar signing off. Have a great and wonderful day and thank you for watching this.